So that research thing's on Thursday next week, huh?
Yeah, the research mixer will be a week from today.
Because that's the only Thursday that I saw that we have. Because the week after that's Thanksgiving, right?
Yeah.
And the week after that, the Thursday is the last day of classes.
Yeah.
So anyway, Maddie can't do the tour at 80 acres. And she just, and then the waterworks guy said he could do it, but the day he could do it is that day. In fact, I scheduled it, but I have to cancel it, I guess. So maybe we can do it on Tuesday for waterworks at least. Someone emailed me and said, like, I don't know who it was, but someone emailed me and they have like 5 people that go to the waterworks. So, but maybe, I don't know, is Tuesday bad for you guys? Because otherwise we can't do it if you're going to have a research thing.
I have evening classes on Tuesdays, but it starts at like 6 p.m.
Oh, all right. Maybe I'll see if we can do the waterworks. He's pretty eager to do the waterworks, this guy Jeff. So, I don't know. I'll see if he can do it another day.
Okay.
Because I just got an email about the other thing. It's like, oh, I just scheduled for this. Plus, Jeff was so nice about it too, so I feel kind of bad. No, but I can see Maddie, like she scheduled that so far in advance, and then it's like we blew it off. I can kind of see why. Right. I put up another homework. Let's see. I think everyone did okay on that last homework. I don't think it wasn't that hard. Homework 11, the thing about the evaporative, and then this thing. Oh, this is about 80 acres. So it's just like I think it's qualitative stuff.
You were having some trouble opening the website for App Harvest. It's not a secure website.
Right. Yeah.
Oops. Yeah, privacy error that shows up.
Yeah, you just have to say it's okay. I don't know why. Anyway, I mean,
I'm gonna steal my information. I did just have my identity stolen.
I don't know what to tell you. You know, like I did it. So far, I'm still alive. But, yeah, that's what I would do. Well, do it on a UC. Do it on one of these computers.
It's a great idea.
Yeah, so you don't have to risk it. But basically, this is what it is, and I mean, it's kind of a slick web page. I think they just didn't bother. No, it's not well, these aren't usually all HTTPS anyway, are they? Oh, I see. They listed it as HTTPS, but it's really HTTP.
Get rid of the S, does it just work? So HTTP?
No, I think it probably won't work, but let's see. Let me try. No. So they've listed it as S, but it's not S. Like they didn't write it as S, they wrote it as whatever hacked up thing they did, but they made a mistake when they listed it. You'd think they would have picked up on that, you know. This is right around here, though. This is down like Lexington. So it's kind of, I mean, it's kind of cool. All this stuff is like near here, you know, like a lot of it is really in Cincinnati. So anyway, I think it's neat. But so yeah, that's what that. All right. So yeah, it's just about that. I don't, there's no other way to get to their website, I don't think. Like if you just put in App Harvest .com, same thing happens. Forget about .com. App Harvest, you get to, this is their web page, right? But if you click that, that's the same web page. No, that one works. No, it still says not secure. So I don't know. Maybe it's just telling you don't give them your credit card number. You go on here. I'm not sure. I'm pretty sure it's the right thing. There's a video of this guy too that's pretty good, but is that linked here? I don't know if that's even in here, but anyway, this thing, this is pretty cool. The somewhere is the population thing. Dick Dosimer. It's like updated. Maybe I didn't update this thing. Oh, I thought I put a link in that's like world, yeah, world population. No, that's not it. There's a thing that gives the current world population. None of these. Anyway, it's a pretty cool webpage. I don't have it linked here for some reason. I thought it was in that, it linked in the homework, but see, probably if you go, and somewhere in here, oh yeah, world population clock live. Yeah, but it gives it by country live too. Like that's the cool part. I mean, this is pretty cool that it gives it live. It tells you how many are dying, deaths today and births today, right? I mean, it's like, anyway, and then top 20 countries live. So yeah, and they're changing, right? The numbers are changing, I guess. Yeah, India's changing pretty fast.
Because India and China was so close together in population. I thought India was much higher than China.
Oh, I thought the other way. China's much more land than India.
It's just amazing that India just had so many more people compared to like the land grant.
Yeah, but all right,
Um,
the spec sheet is all right. They have like immigration and like births and immigration, like that kind of statistic, you know. And then you see, like if you do that, let's see, it's in here somewhere. But if you do that, you find out that China is shrinking, negative population growth. And US is just like, so you need 2.1 or something to survive, like to continue existing the way you are. So I think US is below, it's like just above that, but only because of immigration. And like all Europe is dying. Japan's really negative growth and like serious negative growth. Someplace in here you can get that.
Can you click on the name of the country?
Yeah. I don't want that. That's not that interesting, right? I just typed it in, right? I didn't, so yeah, forget this. I should link this web page. It's pretty cool. Top 20, past and present, future, global growth rate. Yeah. Oh, here we go. All right. Fertility rate. So this is the number that it's going to be 2.2. So, but if you look at like Tanzania, 4.6, right? All the African countries are like above 4, 6.1. Like just look for the numbers above 4. DR Congo, you know, DRC. And this is a place, so they have 7.5 million displaced people now. I put a link to that. They just came out right around Goma near Rwanda, like Lake Rwanda, like the people. So Rwanda had the genocide in '94. When the people went to Uganda, And the refugee camp in Rwanda, in Uganda, was the second largest city in Uganda. And then all the military of Uganda became Rwandan refugees. And then those people came back and like kind of reconquered Rwanda. And then all the people that had conquered Rwanda with the genocide were pushed to the DRC. Rwanda is a little country, you know, it's like 3 million people, maybe less than that. Basically the size of Israel, Palestine. When they pushed all those people to DRC, then they made a huge refugee camp of these kind of like gang, like a 1-2-3 army or something. And they're just going around rampaging, like killing people. So they've driven the people from Congo out. They themselves are refugees. So they end up with like 7.5 million people since '94, you know. It's just been like, it's a mess, you know. No one, right, so all the stuff in Israel, this is like 4 times bigger and no one even cares, you know. You know what I'm saying? Like basically you can see people's focus on certain things and like, I mean, not that it isn't bad, but basically just as bad, you know, or worse. I mean, actually the people, you see the people in Palestine and they have shoes on at least, you know, when they're walking from wherever north to south, you know. But I mean, the Congolese, they don't have shoes, like they don't have anything, you know, so, and they talk about them starving. I mean, they've been starving since '94, you know. So, and then Sudan too. So it's kind of like, yeah, Ethiopia is 4.0. So I guess that's relatively low. And then, yeah, India, so China's negative. Let's see, China fertility rate's 1.2. So they're dropping, right? You need 2.1, I think. I think like Indonesia is right where you need to be to maintain what you have. US is 1.7. So we don't have enough, right? Oh, wait, that's per woman. So maybe that's okay. I don't know if that's good or not. I think it's 2.1 that you need, but yeah, fertility rates per woman. They might define it here. Yeah. Oh yeah, it's wicked scary, you know. Yeah, it's incredibly scary, you know. This is on average. Yeah, I mean, some people have like 20. Yeah, really. I mean, think about how much time you have between like 15 and like 50 or whatever, you know. It's like basically it's one kid that would be like total, as many kids you could possibly have, you know, just like constant. So yeah, so they're all African countries, right? The entire list of all, I did it by fertility rate. It's like Africa. These are all Africa. Afghanistan's the first one, 4.4. Then Sudan's Africa. These are all African countries. I don't know what Mayad is, 4.3, but that's Africa. All these are Africa. Pretty crazy. This is actually worth kind of looking at extensively, this chart. You know, it's actually all the African, there's only 52 African countries, but basically all of them are in the top thing here. I don't know where South Africa is. Saudi Arabia is at 2.4. So I think when you get around 2.5, maybe you're okay, I guess. Bolivia. And we're down at the bottom somewhere. We were like 1.6, right? Hong Kong, South Korea is in trouble. Japan's here, 1.3. So they're like negative 0.53% growth rate. You can see though, for us, it's immigration that's kind of saving us from this stuff. So let's see. This Holy See is the smallest population. To become a citizen, you have to work there. 518. That's the Vatican City, yeah. Yeah. In order to become a citizen, you have to work there. But, and everyone that works there isn't a citizen. So you have to work there and also be like special or something. But
Probably good if they don't give a fertility rate as well.
yeah, it's true. Yeah, right. I didn't notice that, but yeah, it was pretty funny. Yeah, so China's achieved, like, you got to give China credit, like they've achieved, like they were on the 6th level before they had this. So they just said, I have one kid. Now they're negative. So I don't know. You have to we're not doing that, so so for us, migrants, so we get 1 million people a year, I guess. And then I thought these were changing, but anyway, net change is like 1.7 million. So basically, without that, our 1.7 would be like 1. Like we would be a dying country without the 900. Well, it's half, right? So it'd be whatever, 0.8, 0.9. But no, if we're half immigrant with our net change, that 1.7 would be like 0.9, which would mean that would put us with like Japan or something, like basically a dying country. So anytime people are complaining about immigration, tell them, do you want to be Japan? I don't know. There's a lot to look at here, I think, in that chart. I have to link that up. I'll figure out how to get that. This is pretty cool though with the automatic thing. Anyway, so see, I think so I'm just gonna do the same like do on Monday for the homework, even though we missed a day, because it's covering the stuff we already covered. And then maybe if we get too far ahead or something, I'll use some kind of offset. But so far that seems to be okay. All right, slide 215. This thing. So all right, so Ming Ming can't make it today, but she said she can make it on Tuesday to talk about biochar. And then I haven't really said anything about biochar. Let's see, 250.
I didn't realize we were supposed to even have a speaker today. I don't know if it was ever.
I didn't, well, she said last week that she couldn't do it, and then she didn't say like when she could do it. So I didn't say, otherwise I would have said we had a speaker today. But then somebody said that they couldn't make it for the speaker. So I did mention it, I guess, at some point. I'm not sure when. But
A while ago.
Yeah, a long time ago. Yeah. 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 Anyway, she had something going on. She couldn't do it. So I went through, I showed you the video of the thing last time, like a while ago, right? Whatever that was. The retort oven thing, and then that's to make charcoal, basically, charcoal oven. And there's people have people are like growing trees to turn into charcoal or to make wood gas to make electricity. Like in England, they're doing that in a couple other places. And then in Brazil, it's a big operation to get the sugarcane waste. Like they have huge sugarcane plantations, and there's a lot of roughage from it, kind of. So basically using that to make biogas. And the same kind of thing, like it's basically a pyrolysis reactor to make the heating. You heat it up and then you get the gas off. This thing, if you click on it, it goes to England, and they show how they've taken this farm, and then they use the excess heat from the electricity generation to heat up a pool. So it's like a whole neighborhood kind of village electricity operation from a renewable forest type thing. I think this is one of the Brazil biogas factories. So I think Mao Bing 2 is going to talk about biofuel, but it'll be like the Tuesday of the last week of classes. So, so he'll be here. So there's 2 more speakers in that, and maybe we can do the water plant tour. It looks like enough people want to do that. Anyway, so solar cooking, I already kind of talked about this. So I didn't really talk about it, but basically we heard from GoSun kind of what they're doing. The thing with solar cooking is that there's been like a lot of plans for it, like this kind of device, and then manufacturing them in Africa and things, and like it's never caught on because basically people don't cook in the middle of the day usually. Like for the most part, like this is a solar heater oven for a company where they have, and there's one of these, if you're down at the Go Sun, whatever Skunk Works place, they have one of these built where they have a almost exactly the same thing with a mirror array set up in an oven where they focus the light down into the oven. Anyway, there's this group that are doing that for basically they provide this to women in, I think in Ethiopia or in Kenya, I guess. But basically they're doing this also. There's another group doing this in Ethiopia. I think they're linked in. All right, there's this company in Finland, right, that makes these things. It's like a mirror setup that tracks the sun manually. Like you have to move it around and it focuses onto an oven and you can bake things in it. Like commercial baking. They make bread and things. This is what they need in Palestine, like when they have no electricity to run the ovens. So anyway, there's a company that makes these, and then there's a bunch of NGOs that are coupled up with that company to kind of give these away to people, you know. So the company makes these, you can buy it, but mostly their sales, I think, are to NGOs in Africa that are taking these to villages and to basically the one in Ethiopia is going to women bakers, and this one in Kenya too. So they can have a company to bake bread to sell it, and then somehow they have that worked out. They know how to do that. Maybe they pay back for the machine. Not sure, but anyway, there's a video about these machines. So there are like solar cookers that people are using, but it isn't like there are people lining up at Costco to buy one of these. You know, it is so basically the same with the Go Sun. It's a survival thing. Like if you're thinking about end of the world and you need to cook your meat, yeah, you get the Go Sun oven. And that, like a lot of the sales were during the pandemic, and also for like relief agencies and stuff, like for hurricane relief things where they don't have electricity, so you can cook with the thing. So basically, anyway, the solar cooking thing doesn't seem to have gone very far. You know, one of the big problems is that people cook like before dawn. So they get up, like they're working the whole day, and they get up before dawn and they cook. You know, along the equator, it's like a 12-hour day. So they get up at like 5 in the morning, it's dark. Sun rises at 6, that's at 6. Then like they're out by 6, they're gone, you know. So any kind of cooking that they were going to do, that's over. And they get home around 7, it's dark again. So there's no possibility of solar cooking the whole operation, you know. They go out in the fields or they do something else, and they're not there to cook when the sun's up. So even if you had an effective thing that didn't look kind of like junk, or tacky or whatever you want to call it, like these things, like, are people really going to use it? So one of the things, they had a competition a couple of years ago about like got college students to kind of figure out how to get around this darkness cooking with solar. So there's various things, and there's some NGOs that do this. There's a NGO in like northern India that's doing this, where they distribute these giant parabolic reflectors that they make there, you know. So they aren't like a nice parabolic reflector. They're kind of like this thing, right? So it's kind of a hack job, and then goes in through a window. So hopefully your kids don't run by when this thing's cooking, because I'll show you what this can do. Like there's a video I have I was going to show today. Well, what something like that, the kind of energy you're getting out of it. It's just serious. And you can melt pennies and things with that.
I've seen videos of people turning like rock into obsidian using these solar heaters.
Yeah, it's a lot of energy. Even just that, it's kind of like a man-sized thing. Like it's a huge amount of energy you get out of it. So anyway, so what do you do? Like so they have different ideas. Like they take the evacuated tube idea, like the Go Sun, and then put a fluid in it that you can kind of take the heat out. So you can store the heat in oil. So you can have a big tank of oil, heated oil, and that oil could run through a kind of an element you can cook with it. That works, but it's kind of messy, but basically it's possible. Like this is an idea where they have that Go Sun, said the Go Sun parabolic, and the Go Sun heater, it's painted black, and then it's got at the end of it is a bulb, and it's going to store it inside of an insulated chamber where you can use that later to bake. It's like to bake with, you know. So it's possible to do this, and that can last overnight, you know. Those kind of things can last overnight. Different kinds of ideas about like basically end up, how do you insulate the thing? I mean, the Go Sun solution is to have a solar panel and a battery. Then you store the energy in the battery, and you have the Go Sun cooker, You just put a couple electrical elements in it and you run it off the battery. Then you can cook at night. You can cook whenever you want. That seems to work, you know. I mean, it's kind of a viable option compared to kind of clunky mechanical options. You know, this is a competitor for GoSun. This is kind of another commercial solar cooker. This is the idea of that oil. So you have a treadle pump that you pump the oil through. It goes to an element, kind of, which is basically a copper tube, and it's running off this really hot oil. And there's some potential to like kill yourself with this, like because you have like super hot oil that you use in oil that's hot enough to boil water or to fry things with, kind of running through this piping system in your house. So there are some kind of downsides to that. Then some people talked about like have a bunch of rocks outside, some kind of parabolic mirror, then during the daytime, leave that thing outside, let it heat up, and then it's on wheels, so you can wheel it in after. Like here's a picture of that in Minnesota. There's a giant parabolic, then it's heating up kind of a rock bin that they can wheel back and forth. They can take the heat with them wherever they go. It's clunky, kind of like, are people really going to use something like that? Kind of some issues to it. This is a design of this hot oil like burner, more or less. So somehow it's got coiled. Now the problem is like people have the idea like you're going to cook over charcoal. It gives it a certain flavor. It's got a certain temperature. They know how to do it. And they want that stuff. They don't want to have something that's cooked over it. So it's possible to make some kind of native foods with this, but it's not the same thing as an open fire, right? So anyway, so that's kind of some of the ideas about solar cooking, you know, that people have. Students actually came up with these designs for this thing. It's in somewhere on the web, but that's a GoSun thing. Anyway, so that's kind of the fluffy beginning of this stuff. So the next thing I wanted to go through is like let's see, I'm missing something here though. Wait a minute now. I'm missing this charcoal thing, which is on slide 376. No, that's not it. 254. Nope. 215. Nope. Anyway, I guess I'll get to it. Anyway, the next thing is, let's see, let me just make sure I know what I'm doing here. Why was I looking at this thing? Sorry, let me just zip through this and find the thing I'm looking for. Apparently, it's not here anywhere. Why was I looking at this thing today? It's definitely in here. It must be before this. Wait, let me go back to the charcoal thing. Because I have a thing of this Fresnel lens, and let me just see if I can Google Fresnel lens. It's in this charcoal stuff, right? Yeah, this is it. Solar charcoal. No. Yes. This is the Fresnel lens thing. So the Fresnel lens, have you guys seen these before? Let's see, is it going to let me do it? Open link. Let's see, it's because I have to enable it. You told me that. All right. Open link. So like I showed you before, that charcoal. Anyway, I wanted to show you this earlier, but I forgot. So this you can buy yourself. I think you can get this thing on Amazon. It might be worth doing, but This we don't need to see. Blah, 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 blah. So he's going to make charcoal, right, from a shirt. He's going to make charcoal from a shirt using Fresnel lens, a big Fresnel lens with a tuna can. So he figures out it's made of cotton, he stuffs it into the can, and then he's got this giant Fresnel lens. So he's got a vent so it can shoot out the, like with the retort oven, like it's going to shoot out the off gas, and that's going to catch on fire. Like it's basically wood gas that's going to come out of it. This is his Fresnel lens stuff. So it's just all it is like a sheet of plastic, right? But it's got these grooves cut in it. So it goes like ridge, ridge, ridge. So if you could kind of like pull those ridges up so that they were parallel with each other, then it would form a lens that would be like the size of a person, right? So if you take like a lens the size of a person, then just take the pieces of the slope and just bring them down flat. Then just cast that from like PET, like water bottle material, right? And then you just have, basically it's got the index of refraction change of a lens, but it's all on a flat sheet that you just injection molded, just pop them out. So it's like really easy to make. So I think this thing's probably like $10, but what it can do is pretty incredible. So because the human size, basically like that reflector in India, except this is a lot cheaper to make. So he made charcoal. He made charcoal out of that stuff. There's another. All right, so that's used. He's got a video here too of just his lens. So here, like what you can do with that lens, which is kind of more interesting than the making charcoal. It's this thing. It's also got some fluff up front. So he made this giant lens. This is like his promo part. Actually, his video is short, and he's got this promo. It's almost the same length. So this thing's pretty cool. Like, it's dangerous though. Like some things he does, like he pours gasoline. He pours gasoline and it blows up. You know, this guy's a little nuts.
I think he did pass away at some point.
This person?
Yeah.
Oh, really? Have you seen this? All right, everything involves some kind of beer, right? So it's like everything has to have beer in it. Yeah, what he does is a little crazy. The gasoline thing is nuts, like totally nuts. Also, the bottle blowing up, like basically with no goggles on, torching the hot dog, that's okay. I mean, it's a pretty powerful lens. It's just a piece of plastic, you know. Then his kids eat the eggs. It's like so good. I guess that's his wife. He feeds it to the kids too. Yeah, so you can melt a penny with it. Yeah, with just a stupid sheet of plastic, right? We should buy one of these.
Last name.
You need to build the case for it. I mean, with just the lens, I mean, it could be really dangerous. He just sticks anything you can think of. And then finally he sees a lawnmower over there and a can of gas. He's like, whoa, that's a great idea. I mean, actually, he doesn't put that much gas on, but the fact that he has the can of gas in his hand and he's literally like pouring it on. And it's like, what could he be thinking? You know, someone who doesn't understand like flammability. Anyway, I thought the Fresnel lens is pretty cool. You can see like with some simple things, you can just I mean, you could really set up some kind of a solar cooker with that. I mean, I don't know why Patrick isn't using Fresnel lenses for this thing, except it's too dangerous, probably. Right. So anyway, I wanted to get back to that was supposed to be with charcoal. So you can ask Ming Ming about Fresnel lenses. Let's see. So all this stuff. this stuff actually gets into some kind of actual chemical engineering, but not at first. So at first, so if you say like concentrated solar, so the idea is like, what can you do with it? So actually this is already being used in the chemical industry to replace like heat sources for distillation. So you can get concentrated solar and use it for processes. But the thing people are really looking at is making hydrogen. So you can reduce a metal at high temperature, you can reduce a metal oxide, right? And then you can make it, and then you can use that to split water. Like you add water to the metal oxide, it'll split the water and make hydrogen. And it oxidizes the metal, and you put it back through the process and heat it, like cook it through a solar heater. That's this kind of simple idea. And there's like maybe 50 different kind of metals people have tried to do this with. And then also you can do this with sulfuric acid. And you can couple sulfuric acid and a metal oxide. See, there's like various manifestations of this production of hydrogen. It's like the hydrogen thing. Um, the hydrogen thing.
It affects the metal oxide when you're doing that, or is it just
Yeah. Well, the problem is you need to have a nanoparticle metal oxide to do this with, because the reaction rate is going to be like the surface area. So the smaller, the better. But the more cycles you go through, the metal oxide grows larger. So then it's not a nanoparticle anymore. Then you have to throw it away, or like take it and regenerate the nanoparticles from it.
Yes.
Right. So it's basically you're consuming the metal oxide in the process. Like when they do economic analysis, the metal oxide. But let's see. Let me get. So there's some other stuff. So this is the idea. Like, so I did a proposal like over the summer on this stuff, which was rejected soundly. But basically, with some Germans actually. So like the DEFG is the German National Science Foundation, and the U.S. National Science, they want to have projects together. But the thing is, like Germany is really heavily invested in hydrogen for chemical industry, but using this route, right? And basically the U.S. has nothing to do with hydrogen. They're like batteries. It's like coupling the two is kind of difficult, where they're really interested in one aspect and we're interested in a totally different field, right? So that's where this proposal ran into a snag. But Japan is like all hydrogen. Australia is all like sizable hydrogen. Saudi Arabia is dumping a ton of money into hydrogen, and then Germany, and then the EU, because Germany kind of leads the EU, but the UK isn't. Like the UK is batteries, so it's kind of weird. Like the big pushes for different economic solutions. Like my son was just in Japan. He was saying like there's no solar there at all practically, and like all the nuclear plants, because of Fukushima, they shut down all their nuclear plants and they've replaced them with coal plants. So they're building all like new coal plants running off Chinese coal. And basically their footprint is getting worse and worse by the day, because of basically they were getting all their electricity from nuclear before that. And then they decided to shut down all the nuclear. Anyway, but Japan's heavily into hydrogen too. So the idea with hydrogen is you make it, so you can't, the problem with hydrogen is you have to transport it. And it's not a useful thing to transport, because you have to use really high pressures to get to be liquid. And the gaseous transport isn't effective. So basically, you need to pressurize it or cool it down a lot more than what you can do. So you need to have these huge steel ships or something to carry it that don't even exist, right? So one option is to like convert the hydrogen to ammonia, which is a pretty simple reaction. So you can convert hydrogen to ammonia, and then ammonia is just like propane. So basically 1 megapascal, 10 atmospheres makes it liquid. Then you can have these kind of steel tanks to hold it. And also ammonia, you can burn ammonia like propane too. And so you can just put ammonia in. So the idea is like make hydrogen someplace where it's easy to make hydrogen, which would be like wind turbines as far offshore as you can get, like floating wind turbines out in the middle of the ocean. This is what the German National Science Foundation is doing. Like, then they want on-site. There's some people in the U.S. also doing this on-site reverse osmosis of seawater, which turns out doesn't take that much energy to do. Easily provided by the huge wind turbines. So wind turbines like Eiffel Tower sized wind turbines, like huge things. They aren't the dinky ones that you see. And then so do the osmosis of seawater, get absolutely pure water to feed into electrolysis, and then do electrolysis with catalysts that are being developed in Germany to make hydrogen. And then have a reactor on site too to make ammonia, and then just have ammonia. You can just fill up ships with it right there. And you can actually burn the ammonia in the place of bunker fuel in the ships. It's like the dirtiest kind of oil, the highest sulfur oil they can't sell anywhere else. They put into ships because when they get to international waters, there's no environmental laws. Yeah, so the ships are just spewing out like sulfur once they get out into the ocean. It's the cheapest fuel. So it's basically that can be replaced with ammonia. I think it's an equal trade-off, like the same price. You can run the thing on ammonia. So like Australia's got these huge desert in the middle of Australia. I guess they want to just cover that with solar panels. They've already started doing this. And then on the north coast of Australia, have conversion factories to ammonia, fill ships with it, sail them to Japan. And then when Japan already has like hydrogen, like if you look at the distribution of hydrogen refueling stations for cars, like Japan has like one on every corner. It's like they're totally committed to hydrogen as a fuel for cars, right? So basically you can convert ammonia back to hydrogen, another like simple reaction, right? Or you can just burn the ammonia if you want, you know, but so you need to kind of redesign the engines to burn ammonia. But most of the time they're burning ammonia, they're mixing it with diesel or something, like it's a cut, like 80% ammonia, 20% something, like diesel or something like that. So anyway, there's all the steps, so to have a hydrogen. All right, the other step is the water shift gas reaction. So you take like hydrogen and CO2, and then you can make carbon monoxide. And so if you do a reverse shift gas, you take hydrogen and CO, carbon monoxide, and then you can make carbon dioxide and water. Okay, so why would you want to have carbon dioxide? You already have it. But basically, you don't have like concentrated hydrogen, carbon dioxide you need. Maybe you could buy that, but basically you can make it too. So you can do this reverse. You can take the hydrogen they make from electrolysis, run it through a reverse shift gas at high temperatures. You need a solar oven, like 1000 C, and then you can make carbon dioxide and water from that. The carbon dioxide you can feed into a reactor with an iron catalyst, also at a high temperature, solar heated, with hydrogen, and you can make petrochemicals. You can basically make any kind of polymer that you want from that. I mean, basically ethylene type things, polyethylene, polypropylene. Right. So you can. That's the Fischer-Tropsch reaction, right? Taking carbon monoxide and hydrogen and making hydrocarbons. Right. So basically you can. This is a self-supplying thing. If you have a wind turbine or a solar panel, then you can have the whole petrochemical industry. Not only that, but it's like more jobs for us. Like every step of the way here is a chemical engineer. So this hydrogen economy thing is like a self-preserving operation. If you think that petrochemicals are going to disappear because we're killing ourselves with them, then you want to go hydrogen, and then think about renewable, like a green petrochemical. So you have like green plastics coming out of this. They aren't recyclable, but basically they're renewable, kind of. In other words, they're coming from a renewable energy source, not fossil fuels. So this is Germany has a huge petrochemical industry, so they don't want to see it disappear, right? And also they don't have any oil, so they're already like not doing that great because they have all their petrochemical industries based on imported oil coming through the Netherlands. Not only do they not have a port, really, they have Hamburg, but basically everything comes up the Rhine, just like the Netherlands. You know, so they have to like Rotterdam, right? So in the Dutch tax everything that goes through at 10%, both ways. Like when they make the chemicals, they tax at 10. When it comes in as petrochemical, they tax at 10. It's like tax, you know. So that's why the Netherlands is so rich, you know. Anyway, so if they could make their own whatever hydrogen, maybe they're still importing it, but at least there's something that's going on here. Right. So the idea is like go to the North Sea, cover it with wind turbines, have on-site ammonia production, and then just go and tap it with a ship, fill it up and like take it up to Rotterdam and up the Rhine. Then make whatever you want to make from it. Run your Fischer-Tropsch reaction, get petrochemicals. Right. So it's, I don't know, it's kind of like a complicated future, but all the steps of this exist, you know, and they've already been commercially used. So basically they can be improved, but basically everything in this scheme exists. So anyway, I think that in some places this is going to happen, you know. Basically it's going to happen in Australia, Japan partnership, and it's probably going to happen in Germany too, because they're already investing so much into it. It's probably going to happen in Saudi Arabia because they're thinking they have a huge potential for solar power, like huge solar arrays, you know, and they have nothing to do with it because they don't have enough people to use the electricity. And they already have a petrochemical industry. So all they have to do is swap out oil for ammonia, and then they're good to go past 2050 or whenever our death point is. You know, it's like they don't need to have oil, they can just live off the desert, off the sun from the desert. And then the ocean water, like reverse osmosis of the ocean water. That's the way they're looking. And they have plenty of money to back it up. So it's like, it seems like some aspects of this are definitely going to happen, you know, are already happening somewhat. But so anyway, that's kind of one of the schemes, like it's all based off solar, right? So there's a lot of different kind of research efforts that are going on in this stuff, in this kind of area. So that's what I wanted to kind of go through some of the things. So the first part of that business is the simplest thing. The first thing people, so this is kind of an overall like sunlight and then this whole solar petrochemical industry. But you can also use sunlight to make carbon black, a variety of chemical reactions. The simplest thing though people did first, and there's still a lot of research going on in this, is just titanium, which is like white paper is titanium, TiO2. Everything white is, the walls are titanium, nano titanium basically. And all that stuff is, and the more nano, the more white. So it's like good for opalescent, whatever. And it's also catalytic, like it's anatase and rutile, and the anatase is catalytic. So anyway, I think it's anatase is catalytic. Anyway, so the idea is like it's an oxidation catalyst, sunlight activates it. So you're already painting the building, so you just paint it. I mean, you don't even have to use a different paint probably, you know. The titania can be the catalyst, and you can do this oxidation reactions to break down hydrocarbons. So the Japanese actually invented this field in kind of a while ago, before 2000. You know, so I'm not sure when, but basically, but people are still, like Sperniotis did a lot on this, like developing titania in flame reactors. Like if you burn TiCl4 is how they make, so you take TiO2 is like rock or sand. Like there's SiO2 and TiO2. So sand is something like 20% TiO2 and 80% SiO2. So you can get TiO2 from sand, concentrated HCl, you get TiCl4. So it's a transition metal. That's why it's catalytic, but it has something like a tetrahedral, like carbon and silicon, tetrahedral bonding. You know, so in one of the oxidation states. So anyway, I guess it's the 4 oxidation state plus 4, Ti plus 4, right? So anyway, so anyway, yeah, so because it's transition metal, it can do these catalysis reactions. It goes through a change in oxidation state in these reactions. Anyway, so that's kind of the idea. It's got a band gap where it can absorb somewhat light, normal atmospheric light, whatever, Earth light. So it's like band gap 2. So it's kind of in the range for something that could be used with solar. And then this is Japan. Oh yeah, 72. So some Japanese guy in nature. Right. So this is one of the first photocatalytic titanium things. Right. He's doing production of hydrogen from oxidation of organics or something to make using sunlight. Anyway, so like in Africa, that's like kind of useful because people cook with charcoal inside and the whole place is coated with soot. So, and there's a lot of like lung problems that people have studied coming from this. So basically the idea is like maybe paint it white inside or something, or somehow use that paint to purify the air, remove the carbon soot and whatever. These are the things that, this again is like the Japanese, like this Akira Fujishima, right? Which I think is the same guy that wrote that Nature paper. Yeah, Akira Fujishima. Oh, and Honda's the famous guy. Right, so I think there was like some kind of Nobel Prize or something involved in Honda's work with this stuff. Like it's seen as an important thing. I mean, a lot of the environmental engineers do titanium stuff, like what's his name? The guy that's published a lot. What is his name? I don't remember. But anyway, like every environmentalist is doing like chemistry stuff, is doing titanium reduction of things for photocatalysis to kill the whatever, the algal bloom in Lake Erie or something, or whatever. Anything that they want to kill or clean, they use titanium because it's like cheap.
So they started putting titanium in iPhones, is there like reason why?
Titanium's a metal, right? So it's like aluminum. It's light and it's strong. So titanium alloys, that's a whole separate kind of thing. So you can reduce the titanium and get titanium. In fact, you can take TiCl4 and then put it through chemical processes and get the ground state metal. And then you can do like nickel alloys with titanium, or like jet turbine blades, like the strongest thing on Earth other than diamond. It's like the jet turbine blades are one single crystal, each blade. And they're spinning at, I don't know, ungodly speed, right? And if those things break, like the whole plane blows up, basically. It flies apart and just shards and destroys everything. So they have to have really good confidence in those blades. So that's probably why the iPhone's made of it. Super strong metal. And it's also really light. It's light like aluminum's light. It's near aluminum in the periodic table, but it's much stronger. Like aluminum's not a transition metal, and titanium is. So there's differences. In other words, it's going to be like iron, like it can be catalytic. Anyway, so the titanium is like they call it. Yeah.
Was going like this,
Uh-huh.
and they broke the back of the phone before we broke.
Is that right? Okay, well, it could be. Yeah. I mean, you can make a glass out of it. I mean, yeah.
I just assumed
That would be titanium, though. Yeah. Yeah, that would be titanium if it's a glass. I mean, that could be the oxide. Yeah, I've seen that too. I don't know about it though, but I thought the cases are like silver, right? So
yeah.
I mean, that's what titanium looks like.
The back.
Yeah, I think it's I don't know. Anyway, it might be in the glass. I don't know. But basically, the way I see it, it's probably the case, because the case is silver and that's kind of what titanium. Yeah, but I don't know. I have seen the front thing though, with bending it and all, but it still scratches though, I think. Like my phone scratched a little bit. So
Yeah.
maybe you can't break it, but you can scratch it. Probably once you get a scratch, it fails easier too. I mean, there's a lot like you can do antibacterial with it. And people have done studies and all this, degrade organics. Like if you have gasoline in the water, Gulf oil spill or something, you could just dump titanium, but it would be catalytic, which means that when it oxidizes, it could cause cancer too. It's kind of like not necessarily the answer to everything. This is like a bacteria study showing that it kills bacteria. People talk about using it as air filters, deodorizers. This is one of Spinoza's guys a while ago. Not sure if this is like 5 years ago or something, maybe more than that. I was on that committee, but this guy spent like 8 years here. This guy's really smart. He helped me. He TA'd a class for me, a thermal class, undergrad. He's like a really smart guy, but basically 8 years with Smirnotis. And then he went through like producing all these different titanias. So by doping them with a small amount of different metals, you could shift the absorption band. So you saw this solar band, like you want it to be 1.5, and he's tuning it like, I mean, before it was 4 and he's got it like 2.5 or something. So the closer you get to the peak here, the better off you are. That's the theme. So basically, by doing this kind of flame production, you know, you start with an aerosol TiCl4, or you can use Ti with organics on it, and then just mix in a small amount of organometallic and these other guys, and then you just torch it, spray flame. It's a liquid. It's like burning hairspray. I don't know if you ever did that. I don't recommend it, but basically you can do it. You can make a blowtorch with hairspray. Supposedly it's dangerous, but it's a good party trick, I guess. This guy with the Fresnel lens would probably love that. If he wasn't dead, we could suggest like. So anyway, that's one example of many examples of people using titania for this kind of photocatalysis stuff. And then you can make hydrogen with it too, same kind of thing. It's an oxidation catalysis thing. Then people like architects are putting this into buildings and things, so where you can just selectively put titania layer into concrete. And then that's the clean tunnel, the dirty tunnel and the clean tunnel. So tunnels are, for this kind of environmental study, like tunnels are a good place because there's no, like if you're on a road, there's all kinds of junk, people walking around and stuff blowing in, you know. But in the middle of a tunnel, like the only thing you have is from the cars, you know, like the tires and the exhaust and the brakes. So all this stuff in the middle of a tunnel, like a deep tunnel, it's like a pure source for research of what's coming out of cars. It's pretty strange to think, but so a lot of people are like studying inside tunnels, like way inside a deep tunnel. Anyway, here they painted it with titania, and they put up some UV lights or something that would activate it, and then I don't know, cook the soot before it forms. It's some building in Italy that's painted with titania. It's a French, I guess. But this I think is Japan, these buildings. But so anyway, titania is a big deal. Like you'll hear about it maybe from some other people. Then how are we doing on time? Oh, we're out of time. All right, so that's probably a good place to stop. So I'll just talk about this reduction oxidation stuff next time, you know, with it, you know. Tuesday Ming Ming's coming. So I'll send out an email. Then like Thursday I'll talk about some of this stuff, I guess. And then yeah, we have Thursday, Tuesday, and then it's Thanksgiving. So we're kind of almost at the end of the semester. But, yeah. Yeah. This semester is always like that. It's like with the holidays. It's weird, they're all like, the spacing of them seems to be before. You know, like especially the voting holiday is kind of stupid. Like, why wouldn't they have done that today and then had a 4-day weekend, you know? Yeah, it just doesn't make sense, but